How do you match database infrastructure of your tests to something that's identical to your production? We'll have a look at Testcontainers library that helps us achieve exactly that. Specifically, we'll look at examples in Spring ecosystem, and we'll see how to test JPA components. We'll also discuss how to include fixture data for your tests, while at the same time keeping your database tests isolated, so they don't trample on each other's data. The application we'll take as a real-world example is something we've developed over a course of few tutorials, but we'll explain everything you need to know to understand the context and to be able to follow along independently. Let's recap the current state of our application. We have a Docker Compose file which enables us to spin up local instances of Postgres database. While we have local instance running, our tests pass, but after we shut it down, our application context no longer loads, since database we specified in application properties is no longer accessible. Our tests fail. More broadly, we are having issue with testing infrastructure needed for our integration tests. If we want to test our Spring data repositories, we need a database. We could use H2 in-memory database, which is fast, but the problem is there might be subtle differences between syntax and behavior, which might actually lead to green tests but failures on production system. The other solution is to use real database on development machines, but that introduces other problems. What if our application needs not only database, but a message bus, key value store, third-party service? As a developer, would we need to install and maintain all those services? And what about the continuous integration server where the tests run before code gets merged? Thankfully, Testcontainers answers all of these challenges and enables us to make our cake and eat it too. Testcontainers is a library that uses Docker API to start, stop, and handle Docker containers for us, but it also integrates with lifecycle of our JUnit tests, which is the way it ensures we have desired containers started and ready when our tests run. Let's add support for Testcontainers to our project. We'll go to Spring Initializer site and search for Testcontainers and explore newly generated POM XML. It contains the dependency management part that we'll need to copy to our POM XML, and as well as the Testcontainers version part that we'll need to add to our properties. Next, let's go to testcontainers.org site to their Quick Start part to the JUnit 5 Quick Start. We'll find the Maven part, copy it, and add it to our POM XML. We can remove the JUnit Jupyter part because it's already contained in our project, and we defined versions in our properties, so we can remove them from the single dependencies. And we'll also need a module for our Postgres database, so we'll go to Module Databases, Postgres module, and copy the dependency and paste it in our project. We can remove the version and reload the Maven POM XML so the new dependencies get pulled in. We have authority entity repository in our project, which is Spring Data Repository with a custom finder method. So let's create a first test for this repository. I'm going to call it authority entity repository test. We want this to be DataJpaTest. So we'll annotate it with DataJpaTest annotation. DataJpaTest is Spring slice annotation that focuses only on JPA components. It scans for entity classes and configures Spring's data repositories. It will disable full auto-configuration, including our configured data source, and will instead try to use an embedded database if available on class path. DataJpaTest includes add-transactional annotation, which in test context means that every test is rolled back after it's done. Let's create our first test. Can query by name. We won't write any assertions, we'll just run the test to see how we do. And the test fails. Fails to load the application context. Failed to replace data source with an embedded database for test. Test fails because add-data.jpa annotation is configured to try to use embedded database like H2, which we don't have in our dependencies. We need to tell Spring Framework to test with real database instead. If we open DataJpaTest documentation, we'll see that we can do that with auto-configured test database annotation. So let's use that. We'll say auto-configure test database, and its property replace should be none. In other words, use the real database. Let's rerun the test to see what will we get now. And the test fails again because we don't have a real database. The test tries to open our database at localhost 5432 and we don't have the database running because we've shut the instance down with Docker Compose down. Let's annotate our class with test containers and try to use this library to provide us with a test database. But first we'll drill down into the annotation and we'll see that it's annotated with the extend with Testcontainers extension class. This is a class that implements JUnit callback methods and hooks into JUnit test lifecycle. This is the way Testcontainers knows when to start containers, stop them, and how to manage the lifecycle. Next, we need to tell Testcontainers which Docker containers need to be run for our tests, which we do by marking a field with @container annotation. If the field is static, a container will be started and stopped once per class, before all and after all. And if the field is instance field, container will be started and stopped for each test. We'll need to give Docker image as a parameter to constructor, so we can run any container, including our own, by using generic container. So this is what I'm talking about. This will be a new generic container, and constructor takes in Docker image as a parameter. But for commonly used services like databases, Testcontainers offer special modules that expose method that makes sense in the case of certain containers, like getURL in a case of Postgres container. So we'll use that instead of generic container. So we'll replace generic container with Postgres SQL container. And the field will be as well Postgres. And we'll need to provide an image name, Docker image. And we'll use the one we've used in Docker Compose so they would match. We've used Postgres 13. So let's try to run our test again and see what we have now. And the test fails again. This time, again, connection to 5432 is refused. Check the hostname and port. In our Postgres container, we haven't specified in which port it needs to run, and in fact, we can't even do that. If you look at the available methods and go for port, we'll see that it only has with exposed ports. And this is the port that Docker image exposes for a service it provides. And this is the port Testcontainers will poll to know when the container is ready. Testcontainer then uses a random ephemeral port to map exposed port for something that we can use. If we have a look at full log, we'll see that Testcontainers indeed try to start a Docker container for our Postgres database. If we try to search for connecting to localhost, we'll see that it was started on 2375 port. That debug information is overwhelming, so Testcontainers actually provide a way to reduce that by recommending logback configuration. And they recommend we create logback test XML, so in our tests folder we'll create a directory for resources and we'll create a file there, logback test XML, and we'll copy the value Testcontainers recommends us to use. If we have any problem with containers, we can change the level from info to debug. And if we try to run our test again, we'll see that the debug information is greatly reduced. And we see that the Docker container is being started. Of course, the test fails again, with the same message that the connection to 5432 was refused. What we have is, what was first question, chicken or the egg? To use real database, we need to specify URL, username, password information in our application properties. But database we can use in our test is only known in runtime, after Testcontainers picks random port. We need to somehow tell Spring that properties in application properties are not correct and that it should use dynamic properties instead. For that purpose, Spring offers dynamic property source annotation that we can use to set up dynamic properties. And as a parameter to our method, we'll get dynamic property registry, which is where we'll set up dynamic properties. And we'll say add property Spring data source URL. This will be the URL that our container gives us. And this needs to be method reference, not a method call, because this method will be called at the appropriate time by the framework when everything is ready to be set up. And we'll do the same for our other two properties for our database, which is username and password. Let's try to run our tests after we've done that. Hooray! We don't have any assertions, but our database was correctly connected to and the test ran successfully. Nice. Let's create our first real test. So we'll auto-wire the class under test, which is our authority entity repository. And just to remind ourselves, our authority entity has name and provider fields, and our authority entity repository has find by name method. So we want to test that find by name finds newly inserted authority entity. So first we'll insert new authority entity. We'll say it's test and login provider is app, and then we'll try to find by name test and make assertions on the value we receive. So we'll use assertions from assert from J. So assertions, this one. Assert that, test, and actually we can import static method. Has value satisfying, and first we'll write test that fails. We expect the ID field to be filled with a sequence after the test authority entity has been inserted. So we'll say that assert that authority entity get ID is null. Let's run this test. It should fail. And the test indeed fails. Expected null. Actual was one long value, so we'll say is not null to make the test pass. And we'll also assert that authority entity get name has value actually is equal to test, and assert that authority entity get provider is equal to app. And if we run this test, we get a green check mark marking that our test has passed. And if we have a look at the complete log, we'll actually notice that after our database has been spun up, our liquid-based migration also ran. That means that this test also tested the correctness of our migration. Pretty nice. In fact, if we go back to our authority entity and provide incorrect name for the table name and rerun our tests, we should see that we get a failing test because our migration and our entity correctness would fail. And indeed, we have a failing migration, authorities 1 does not exist. So these tests will save us from having incorrect entity mappings. So we'll return it back to our authority. You may ask yourself, do we need this setup? In every test class we need a real database? Luckily we don't, but first I'll show you a temporary solution that could work, and then we'll switch to our final elegant solution. A temporary solution is to extract these properties into an abstract class. Let's say DBAbstractTest. And this will be an abstract class. It will have this dynamic property source. It will also have Postgres container. And it will have our Testcontainers annotation. And then we can extend our test from this abstract class. And then if we run our test again, everything should work as normal. Indeed it does. And since we are setting up these dynamic property sources in our application, we could also get rid of this auto-configure test database annotation and set up this property dynamically, so in our registry. And the property is Spring Test Database Replace, and we'll set it to none dynamically. And now our test kind of looks clean, it just extends from DBAbstractTest. If we run it again, it should pass again. It does. If we go back to Testcontainers site and search for URL, we'll see JDBC support and JDBC URL examples. Testcontainers provides a special syntax for their Testcontainers JDBC driver that will mediate between our application and container and set up correct username, password and URL dynamically so we don't have to do it ourselves. For Postgres, it's JDBC TC Postgres, image version and then the database name. Notice that there's no host and port specified in URL, and we also don't have to specify username and password. Testcontainers will set that up automatically for us. We'll use this URL in our application and new Postgres profile and activate the profile on tests we want the real database on. This is the way we'll get rid of the boilerplate and that abstract class extending. So let's copy the URL, go back to our application and create new application Postgres properties. And we'll paste in the URL, and this needs to be Spring Data Source URL. We'll change the database name to our SS2C, and tag, the version for our Postgres will be 13, as in our production environment. We can also go back to our DBAbstractTest and set up this property Spring Test Database Replace to be none for our Postgres profile. With that, we can go to our abstract test, delete it, delete anyway, and go to our authority test, remove that, instead say that the active profile is our Postgres profile. And if we rerun our tests, we still get a green check mark. Nice. And we have a really clean syntax. Active profiles Postgres, and just a simple application Postgres properties file. If we go to our main test, Spring Boot test, that test that the context loads, this is a test that failed previously. It should fail again, just to make sure. Yes. If we mark it with active profiles, our Postgres profile, we'll say that it needs to spin up the real database, and this time the context should load properly. Let's test it out. Nice, it passes. In our application, we have app user service. It's a service that uses our repositories, so our database. So let's create an integration test that we won't mock our user entity repositories and authority entity repositories. Instead, we'll spin up a real database and see how our service behaves. So we'll create a new app user service integration test. We'll mark our app user service integration test with Spring Boot test because we want to spin up the whole context. We want to spin up our service and both our repositories as well. And of course we want to spin up the real database, so we'll mark it with the active profile Postgres. Our app user service has create user method that we want to test. So we'll auto wire our app user service and create a new test, should create user. And we'll assert that our app user service user exists, let's say test user, that needs to be false at the beginning of the method. It will be true once we create the user. And we'll create the user by using app user service create user test password test. And to demonstrate something, I'll duplicate this method. Should create user 2, and we'll run our tests together. And we see that one test passes, the other one fails. We'll also notice that should create user 2 ran first, which is an important point about JUnit tests, that order of method runs is random. One of our tests failed because previous method created a user and left it in our database. So first assertion in other method was that user should not exist, which is not correct anymore. Unlike DataJpaTest, which contains a transactional annotation and rolls back every test, Spring Boot test annotation does not. So if we want this behavior, and in the case of tests that include database we do, so the tests are isolated, we need to mark our class with @transactional. And if we rerun our tests, this time they should both pass. Nice. I'll remove the second test method. We don't need it. It was there just to prove a point. Let's discuss how can we load and use test data in our tests. We are using Liquibase as database migration tool, and it has the ability to load data from various file formats. We could also generate data from our Java code directly. Third option I'll show is to create fixture SQL script and to load it on a class or single test where we need it. Our app user service has a method to delete a user, so let's create a fixture script that will create a dummy user and then we'll use it in a test method where we'll delete it. Let's go in our test folder under resources, create another directory, call it db, and under that create another directory called fixture. And in there we'll create a file dummy user SQL. What we'll do is just insert into our users table that has multiple fields, but username is primary key, and it will be enough for our test to prove a point. And we'll call it a dummy username. So we'll go to our app user service integration test and create a new test. Should delete user. And the way we load the script in our test is by using SQL annotation and providing a path to the file we need to load. So the path was db fixture dummy user SQL. And now we can actually copy. This one will first assert that the dummy user is present. Script needs to load it. And then we'll call our app user service delete user dummy. And then we'll assert that dummy user is no longer present in the database. And nice, we get a green check mark. Additional tests will be available in a repository linked in the description, but this would be enough for us to make the point we wanted to make in the video. Previously, our whole test suite failed, so let's run it again and see what do we have this time. And see how much our tests last. What we'll notice is that Testcontainers raises only one instance of the database and uses it for all our tests. So we need to especially make sure that we use transactional on the tests that use database, so we don't trample on each other data and keep the test isolated. To conclude, we saw that after initial setup, Testcontainers offers an elegant way to test our application against the infrastructure that is used at runtime and integrates seamlessly into JUnit and Spring's test lifecycle. We no longer have to make concessions and test against an in-memory H2 database. And best of all, Testcontainers offers modules for most common use cases and generic containers if we need something special.